Hey, how's it going, Aunt? Well, it looks like they're streaming on Vimeo. I'm just going to be watching some of the Maxon presentations this morning. Looks like we've got 9 minutes still. So one thing I saw that was really cool, I guess Octane Render is going to be available in Unreal Engine. I've been meaning to learn Unreal, but haven't gotten to it. So I'm not sure. I know that Unreal is used a lot for like real-time rendering. So I wonder how that works with Octane, because Octane is not exactly real-time. But I guess you can utilize some of the, like if you know a lot about Octane, then you can maybe work in the Unreal Engine to begin with, and then when you want to switch it over to Octane, you can. I'm not sure. I'm always really impressed by these photorealistic, like architectural renders that they do. It just looks very realistic. So as the release of Octane Render for Unreal Engine, the world's leading AAA game engine, comes at a very exciting time for the industry with the emergence of ray tracing hardware this year. We now have a pathway to finally bring cinematic and real-time pipelines together for millions of artists. So yeah, that's cinematic compared to real-time, which would be Octane versus whatever the Unreal renderer is. In the next few years, we see this integration paving the way for next generation media production pipelines, where real-time game engines, cinematic, path-traced rendering, light field displays, and cloud computing come together to make producing stunning, immersive, holographic possible for the first time. What does that mean? Immersive holographic? Otoy and Epic Games have shared a mission to make high-end, Hollywood-grade 3D tools accessible for artists around the world, and we're excited to see what they can create in Octane for UE4. Man, if you haven't checked out some of the real-time Unreal stuff, it's crazy now. The technology has gotten so advanced. Like, it's almost there, guys. You're not going to be able to tell what's real anymore. So yeah, we'll see what Maxon has to present. Their first talk is major announcements. So we'll see what they have to say. I'm guessing they'll talk a little bit about Redshift, maybe an upcoming version of Cinema. We'll see. Just waiting on the presentation to start. Should be some announcements coming out.
Wow. Pointed that the wrong direction. Good morning, Siggraph. Good morning, interwebs. I'm Paul Babb, head of worldwide marketing for Maxon. It's been a crazy year since a lot of the switchover, and it is my distinct pleasure to introduce our CEO, who's going to be telling you some great stuff that's been happening the last year. Everybody's been working their butts off, and I should say, my name is Paul Babb, and I approve of this message.
Wow, good morning, everybody. I, for one, is extremely excited to be here at Siggraph this year. I'm with the most passionate company that I've gotten to work with, and we really live our vision statement, which is 3D for the real world. And when you're here and you get to meet some of our employees, or if you're out and about and you're talking to our employees, I think you'll really feel that they live every moment for making artists have the ability to create better and higher quality 3D content. And that's what we live and breathe, and that's what we're going to continue to do. And that passion makes it really, really fun to work at Maxon. And the artists that we get to work with is the joy that we have. And so everything we do is to make people creative. And today we're going to talk about how we're going to allow more people to be creative. And so let's get started. So we do want to talk about, obviously, our new release. Every year at Siggraph, we bring out new stuff. And so this year, we're going to have a new release. It's going to be out in September, and we're very excited about it. It's a great release. My favorite feature is Field Forces. This year, we had the distinct pleasure of being part of the SciTech Motion Picture Awards for MoGraph, and this year, we're going to add Field Forces to the MoGraph toolkit, and it allows you to use the power of fields to control dynamic forces in animation. And it's my favorite feature because it's just fun. I mean, it's fluid, it's real time, it's just a blast to play with, and what people are going to create with this is going to be just great to see. At the same point, we're also going to, the basics of 3D, the first thing that most people learn in 3D is sort of extruding text. So we're going to be announcing a brand new caps and bevel feature that gives you really easy to use control of creating those caps and bevels. And it's not just for 3D text. It's for anything that you want to use, any of the spline objects. So you can use it with lathes, lofts, and sweeps. And you just get some great, amazing effects. And it's just as easy as it should be that you would be expecting from Cinema 4D. We're also going to be announcing great new character animation features. So we have a Mixamo rig for doing automatic rigging using Mixamo. You can take those characters in and immediately just have them automatically rigged and be able to create different walk cycles, animations between those cycles, and it's going to really make it easier to do that character animation that you do so often. Oop, that was one too far. Oh no, technical problems. Let's do that again. Excuse me. All right. So real world 3D is about efficiency. So this release is extraordinarily fast. We've accelerated in all sorts of places. What we're showing here is the new Intel Open Image Denoiser. And what you can see is that you can take what would be a lower quality render in the past and immediately make it super high quality and fast using the denoiser from Intel. That's going to work with our standard renderer, but also because it's a post effect, it's going to work with Redshift and all those under renderers out there. And it gives you the ability to do production quality renders much faster than ever before. We also have the new Embry library, and we'll be talking with Intel tonight to show you how powerful that is. And for keyframing, projects with a lot of keyframes, it's going to be noticeably faster and just across the board a better application to use. But it's important that Cinema 4D stays up to the times. The operating systems, the GPUs, everything is changing, and so we're investing constantly in the core of Cinema 4D to make it faster and up to date. So in this release, we have high DPI on Mac and Windows, which makes it look really, really good on those expensive monitors that everybody has. We have all support for the new Mac features, so we're ready for the new Mac OS that's coming out in the fall. We have dark mode and a menu bar and all sorts of great features for those Mac users out there. We're up to date with the latest Windows operating systems, and we're using the latest stuff from Intel and AMD for the performance. That's just some of the features that we're highlighting today because we have a lot more to talk about. But this release has a ton of other stuff. So it's got volumes, it's got the macOS support that I talked about, it's got nodes. We're having all sorts of trouble today. There we go. All right, we're back. And it's just got a lot of other features. It's going to be live on the website in a few minutes. There'll be videos and descriptions of all these features, so check that out. But we not just have Cinema 4D this year. It's the first time coming to Siggraph, where we're joined with our new friends from Redshift. They're right over there, so go see them afterwards. They have a ton of stuff to show as well. So we're showing all the new Redshift stuff. They're going to be showing off Redshift 3, which is in a preview release right now that you can work with. It's got RTX support, so it's extremely fast. It's extremely fast without RTX because they've added all sorts of new optimizations. They're also going to be doing a sneak peek of Redshift RT, the first time it's going to be shown. So go take a look at that. It's very exciting. We're also announcing today that Redshift is coming to Google Zinc. So we're showing Google Zinc with Redshift behind us. So now you have Cinema 4D and Redshift on Google Zinc. So we're very happy about that. So we have all sorts of stuff going on. And as they announced at WWDC, they're working on the metal version of Redshift that'll be available by the end of the year. So we're really, really happy that Redshift's here with us. Go take a look at their booth. They're also behind us, and they have a pod back here as well. Real World 3D is also about integration. We know that no matter what project you're working on, Cinema 4D is not going to be the only tool that you're using. You're going to be using tools throughout your entire pipeline. You're going to use stuff from Adobe. You're going to use some CAD apps if you're using visualization. You're going to use Substance. You're going to use Zinc. We're going to be open constantly going forward. We're going to make sure that all these products can use our file formats. We're going to be using their technology. We want to be about real world 3D, and that's not about locking anybody in. It's about being open. So with that in mind, last week, Unreal announced support for the Cinema 4D file format. And that's just exciting news if you want to use Unreal to do your real-time visualizations. That was huge news for us. They've been a great partner. They're showing
That is
stuff
huge.
to take a look at it. But today we're going to also be announcing that we're going to be working with Unity, and we'll be releasing a plugin for Unity in the fall that gives you that same level of support for
That's awesome.
in Unity. So again, thank you. If you want to use Cinema 4D, it's going to work in your pipeline no matter what pipeline you're using. So that's 3D for the real world. But we talked about the idea we wanted to talk about something bigger than that today. So 3D for the real world is what we've lived and bred, and Cinema 4D is that, right? And Redshift is that, and the people at Redshift have the same view. It's about making the artist more powerful. But I truly believe that there's more to what we've been doing in the 3D industry. I don't think the 3D industry has really opened itself up to be a mass adopted industry. I know there's a lot more designers and artists out there that want to do 3D that have had the opportunity to do today. So today we're announcing a new initiative called 3D for the whole world. We want to get 3D in the hands of everybody who wants to create a beautiful 3D content. And so what does that mean? If you go to our website an hour ago, we just turned it off, so it's not right now, but if you went to our website an hour ago, you'd have a really big choice of how to use our products. But they're all the same products, and they just have random feature sets mixed together, and it's really confusing. And a customer doesn't want to go through that. They want to come in and say, what do I use to create 3D? And the best thing to create 3D is Cinema 4D. So after today, we're only going to be selling Cinema 4D, and we're going to be selling Cinema 4D Release 21. So we're very excited about that. We're going to get rid of any confusion in the market. It's going to be the one and the best Cinema 4D. It's going to have all the features of body paint, prime, visualize. All of them are together. It's going to look better. It's going to run better on your machines. And we're not going to waste engineering time just confusing ourselves by having all these different versions. So a friend of mine reached out to me like 2 weeks ago, or maybe it was a month ago, and said, if you don't fix this, I'm going to be upset because I have friends of mine who want to buy Cinema 4D and I can't. They're in a region and they don't know how to buy it. I mean, how do we want to make software that people can't buy? So we're going to change that. Cinema 4D going forward is going to be extremely easy to acquire. That means we're going to bring out a new global online shop that's going to be available around the world. It's going to be extremely easy to use. There'll be almost no choices because we only have one product. So you're going to be able to go to our website, download a demo, get started with the demo right away, buy the product and not have to read down anything, not have to do serial numbers, not have to do registrations. You're going to have a product that you can use right from download to creation. And we're really excited about this. This is going to come with a new entitlement system, so you don't have to worry about losing your serial numbers. You don't have to worry about how do you go from machine to machine to machine. You're going to be able to just take your entitlement with you and go from your office machine to your home machine. And we've been listening to our users on how to do this right. We're not just going to make it hard. You're going to be able to say, oops, I forgot my software running at the office. I'm going to go home and I'm going to turn it off, and I'll be able to switch over. It's about using the entitlement that you have wherever you want, extremely easy. And it's going to be easy to manage. So we're announcing My Maxon, where you'll be able to log in and see all the versions that you have available to you so that you can manage them and see what you have updates to, see how many command line renders you have, see how many versions of Cinema 4D you have, etc. It's going to be extremely easy to manage, extremely easy to register. You can sign up with your own registration. You can sign up with some of your social logins. We're not tracking any of that stuff in any negative way. We just want to make it easy for you to use it. So, 3D for the whole world. Every industry in the creative space started with selling stuff for thousands and thousands of dollars. If you wanted to do video editing 20 years ago, you would have been paying $20,000 for a video edit suite. If you wanted to do photography, you're paying thousands of dollars. If you wanted to do desktop publishing, you're doing thousands of dollars. But as each of those industries became mass adoption, they had to fix that. It's not okay that we're charging $3,600 and a subscription on top of it to stay up to date. That's not 3D for the real world. That prevents people who are getting started from learning the software that it's going to allow them to create beautiful content. There's companies right now who are asking for almost that on a yearly basis, and then they're turning around and raising the price. We want to give it to everybody. We want everybody to have the ability to use our software because they're going to create the best content with it, and they're going to become people who join our family. And there's so many artists here that this is critical for us. So we're going to change things. We're going to get rid of that. We're going to make 3D affordable. And we're going to do it in a fair way. There's not going to be a European tax. Some people like it. So what we're going to be offering is a new version of our subscription at $60 a month. Or 50 euros a month. That's on a year commitment, and that's without tax. So there is tax on top of that. But that's the base price to get in with the entire Cinema 4D. But we're also going to give you the versions that you want because we listen to our customers. We know what they want. We're not just going to force things on you. So we're going to offer a 1-year subscription to Cinema 4D for $60 a month. We're going to give you a month version for $95 a month. This means you can get in and you can try it, you can use it, you can scale up, you can scale down. And we're going to, of course, continue to offer a perpetual. And we're even giving you a price cut on the perpetual. And the perpetual will have an upgrade program. MSAs are gone, but you will have the ability to do upgrades on your perpetual. But the subscription is going to get you more features, faster, and it's going to be easier to use. But we also have Redshift. And Redshift sells their product, and they continue doing that the way they always have. We're supporting all the DCCs. There's nothing there. But we do want to give Cinema 4D users that use Redshift ease of use again. We want it to be automatic that you can get Redshift really easy. So we're also going to offer the option to have a Redshift bundle. And so the Redshift bundle for Cinema 4D will be $82 a month, or $116 to $117 for a monthly subscription. So we really want to go out there and tell the industry that thousands of dollars a year for 3D software is not okay. We want all those customers to join us in Cinema 4D for the most powerful, easy-to-use 3D application that all the designers and people out there can do it, and we're not going to take away your choice. We're still offering floating licenses. We're still offering multi-seat discounts. If you have an MSA, we're giving you a great discount to get in, so come talk to us and we'll get it started. All of this is going to be available at the beginning of September, And we want the industry to take notice that it's not okay to be charging this much for 3D. Everybody should be able to do it, and everybody should be able to afford it. I mean, so the Maxon team has worked their asses off on this, and I want to thank everybody. Everybody put in a massive amount of work this year to get this done. I mean, we changed up the entire company to make this possible. And so I want to thank everybody at Maxon and all the people who've worked with us, all the artists who use Cinema 4D for helping us get this right. But we're also going to do a little bit further. We want to do the whole world, so we're going to get a part of it. In the fall, we're announcing a 26-city worldwide 3D tour to show off Cinema 4D and get all those new users started with a new affordable package. So come see us, sponsored by NVIDIA, Adobe, and Dell. We're going to be 15 cities in the US, 11 cities in Europe, and we're also getting interest in Asia, so we'll be trying to get around the whole world. But we'll be out and about in the fall, so come hang out with us, get to know us, let us help you use 3D and make amazing things. And of course, Siggraph. We love it here. We have a great new release we want to show off. They're going to do a better job than I am showing all the features. But we also have the most diverse set of presenters we've ever had. They're showing off all sorts of different amazing works. So please come by and see all the stuff that they're talking about and all the stuff they're showing. Come join us and help us make the products better.
All right, guys, there's some pretty cool announcements they just had if you missed them. So Redshift apparently now has a real-time render. So we gotta check that out. There's gonna be Unreal and Unity integration, meaning you can take your Cinema 4D files and open them in Unreal and Unity. It's pretty sweet. Oh, they got rid of all the different versions of Cinema. Like they used to have the broadcast, they used to have the studio. Now they just have one package with everything available, which I think is a smart move. They talked about Google Zinc integration. So Google Zinc is a cloud rendering service that Google has been rolling out, and so now they have Cinema 4D and Redshift available, and I think that one is pretty huge, because if you can do some of this GPU rendering in the cloud, like, that's a great option. And so now they're offering a subscription. It's going to be $60 a month for Cinema, which is nuts, because before it was however much, $3,500 for a single license. Now you can get it month to month for $60. And those were the major ones I picked out. Pretty awesome stuff. So now I think they're going to go into some of the presentations. I'm not sure if Redshift has a stream we could watch, because I want to see what they're doing with their real-time rendering. That sounds sweet. See if we can find it here. Maybe on their YouTube channel. I'm pretty sure they have a YouTube channel, right? Yeah, I'm not sure. If anyone knows if Redshift has a stream, that would be cool to watch. Otherwise, we'll just wait until the next Maxon presentation. Which should be using Cinema for film screen graphic with Marty Romances. Yeah, no streams, just the Maxon one is the only one that I can find. I really want to check out that Redshift real-time render though. Presentation will be available online for viewing, later date. Alright, yeah, I guess we'll just wait for the next Maxon presentation. Where does everyone get their Siggraph news at? I found one article on this website about Octane coming to Unreal Engine. I think it's really interesting how a lot of these programs are crossing over, because now you have Octane in Unreal as well as Cinema 4D, and now you can import your Cinema 4D files into Unreal. And Unreal is insane, guys. If you've only used Cinema, there's so much crazy functionality in Unreal because it's a video game engine as compared to like a motion design tool. I want to learn more Unreal for sure. So we can check out the Otoy Twitter, see what they're saying. Or we can just watch the Twitter hashtags as well for Siggraph. So they're talking about the integration. Oh, this looks cool, guys. You're gonna want to watch this. Some feature UI stuff. First video game, tennis. 1958. The Atari, 1979. NES, 1985. The first GPU, 1999. First ray tracing GPU, 2018. Pervasive ray tracing. Didn't expect this many people to care about rigging. Look at all these nerds. Wait, what kind of rigging? There are so many people in that room. Oh, this guy's wearing a Houdini shirt. This would be fun to go to one year. I know that Siggraph has been going for a long time. For like over 30 years, I'm pretty sure. It's just where all the new technology gets, the new graphics technology gets released. All right, here we go.
Thank you. Thank you, everyone. I have to say that we do create this, we do help directors tell their stories. It's thanks to people like Maxon and people who are developing the tools that allow us to do those things. Passion, which is creating all this, these sort of graphics. And here you will see games and films in this reel, but also we are very in touch with products, real experiences, and prototypes. I'm even wearing today one watch that we designed, and for it we also use Cinema 4D and the cloners to all sorts of stuff that we do, and how important it is to be here, part of this family, which is Maxon. So we're very happy and honored, to be with the technical award at the Oscars this last year. Thanks to them, the motion graphics community and MoGraph in general is having the attention that it deserves through also Motion Pictures and the Academy. So I want to start just looking at point clouds, and that's because it's something that it's very easy and everyone could do it at home. And it's something that we use a lot for some of those very technical ways to visualize different things. We even use it for the most grossing film of the whole history. So something very simple that everyone can do at home, even now more accessible with the new subscription system. It's something that's incredibly powerful, that you can have these at home. For this film, the character that we were having on this karaoke bar that the directors approved was this one, and of course we modeled it, and thanks to we also were very happy to be able to use Alembic system, which is using so many different 3D softwares to help our pipelines with our Cinema 4D users and implementing otherwise. Lots of MoGraph when we were creating these platforms was used, as you can see here. And the final product is this. And the fun part about this is all of this we put into a LED screen that was living on a set at the very end of this bar for Endgame. And you can barely see that, but that tells you how much attention Marvel and all these productions put into these little things and these little details. This is a video where we were building the set in there, and you can see all our graphics around the little dancers that we created, and this is just to build that world with them. So even some of these other animations on the other screens were created with MoGraph, but what I want to focus on is this mask. I don't know if you realize that the concept has a floating LED mask in front of the two dancers in the back. And what we started doing is we started sharing with the directors and production designers and all of the playback team different options for this. And what I want to show you today is how to very easily achieve those point cloud passes with Cinema 4D. So we're going to be looking at these very quickly and show you a couple of different ways to do it. But also I want to show you, we use it in most of our animations and renders, whatever it is to highlight a point on this suit, the shoulders. So what I'm going to do is I'm going to jump right in. Before that, also I want to show how does that look when we're applying it into our layer systems. Because we don't have the ability to have to render these things very quickly on set, we need to go there with all of these pre-rendered passes that would allow us to highlight different things into these animations. How this actually looks when so this right here is our point clouds, and what we're doing is masking in the different areas that we want them to be affected. So now that we understand how we use these little things and how also we highlight all the things with masks and point clouds, let's jump into how we create these point clouds. That we are actually doing it in different ways. Let me just quickly render this. So we're going to start with looking at the geometry of these masks that we were looking at. Actually, the first geometry that we got is the one that wasn't subdivided. So let me show you how this first geometry was looking for. This is the subdivisions that we had. And what we're going to be doing now is showing the fastest way, in my opinion, to render a point cloud. The fastest way to render a point cloud for us, we discovered, is the hair system. The hair system, of course, is made, but we use it in a different way.
We're getting a little buffering issues. Maybe just try and keep it at 720.
Little hairs. These hairs are still not doing what we want, because what we want is a completely white point. So to do that, we're going to go to the shaders, create a hair material here. And inside of the hair material, what I want is white. So the only thing I want is just to have a white point. I'm creating a white hair material. I don't even care about the specular. This is a point cloud. And what I want to make sure is that the thickness is also very, very thin. So I'm going to also change this to 0.1, 0.1. Everything is at 0.1. And as soon as I drop this hair material into this geometry where we applied our tag, as soon as I render this, you'll see that it starts doing something. We start generating points all over the place. We don't even need to see the face. So what I created is a black material that will go right before all of these tags. Now when I render, I only see the points. It's still not doing what I want, and I think these points also look very, very big. So I can even like decrease the length here, or I could go into my hair material and even decrease the radius of this hair. So I could do that, and automatically, automatically you'll see how these points are starting to give us this little lighter effect. And you see how fast this is rendering. It's still something that I don't like, because we're rendering this into the surface. If we change this to points now, you'll see how we're going to quickly render a point cloud on each vertex. We can even like go smaller if we want. And the important part of this, how the render is super quick. I just press render, and if you have this in a massive Alembic file or a multi-million polygon big model, it will go that fast. And the good thing is, like, I can actually have more subdivisions now if I want. I can select all of these polygons and press US to subdivide it. All of a sudden, our point cloud is getting way more dense because we have more points to look at. So the same thing that I was looking at this other one, as soon as you start subdividing it, you start having all of that. This is as simple as that. The problem is that sometimes, depending on your geometry, depending on how close you are from it, you lose some points. And that's why I want to show you a completely different way to create a point cloud that will give us a bit more, a little bit more, it's going to be a modular system that we can, tweak a little bit more and have more variations in the points. And we're going to do this with our friends, the cloner effectors and all of that, and MoGraph effectors, by just creating a cloner. And instead of using hairs, in this case, we're going to clone very tiny spheres. Of course, this is a big spheres. I can just do a very tiny sphere at 0.01 centimeters. I drop this into the cloner. And now we are cloning these spheres here. They are so tiny that you cannot even see them. But what we want is to clone the spheres around this model, our geometry. Let me just delete all of that. Even delete this shader effector. This cloner is now cloning a line and linear. What we want is to clone an object, our object. So what I do change this to object, I have this fill here where I can drop my face geometry, and all of a sudden we will see, one second. You will see that these tiny points now are cloning at a surface. If I increase the count, you will see how these tiny points are starting to appear. We can barely see them, so I'm going to just make these spheres slightly bigger. You can see them now. What we're cloning is the surface, and that's not what we want. I mean, it could be what I want to, if I want to create that lighter effect. If I keep increasing this, we can start seeing how this looks like. But that's not what we want. We want to have these cloning it on the vertices. As soon as I change this distribution to vertices, now we start seeing those vertices rendered. Now I can go back to make this slightly smaller. And we can start seeing that when I render this, we have the similar effect that we were having before. Pretty fast render as well. Now this cloner now can be duplicated. We can change this from the second one. I don't want them in the vertices. I can have them on the edges. We can have here, let me just turn this on so we can see a little bit more what we're doing. We can see how these little spheres are now, ones are in these vertices and other ones are in the edges. The ones in the edges, you will see that I can even offset them. So I can maybe create animation, or I can create different points that are not right in the middle of the edge. And the good thing is, like, I now have the opportunity to change this to maybe I want the vertices one to be slightly bigger, so I can do that. And I'm starting to now have 2-point clouds here. One that is the smaller one in the vertices, the other one is the bigger one in the edges. So this is not even finishing here. I can add another one to clone on the center of the polygons. And we can do that right now. By just duplicating this cloner, I can change this distribution, not vertex, not edge. Now we're going to the polygon center. And we can see now we're adding another extra step. And we can even say, you know what, this one I don't want to clone a sphere. I want to clone a cube. So instead of the sphere, let's get rid of the sphere. We can clone cubes. Let's make sure that those cubes are tiny cubes as well. I'm going to copy the same value. We're going to create a very, very tiny cube. And you can see now I have these cubes on. I'm going to copy the same value. We're going to create a very, very tiny cube. And you can see now I have these cubes in front of every single polygon and the other ones on the vertices and the edges. That gives us also the opportunity to separate different things and highlight separate parts of this geometry. I could actually go to this geometry where we actually will see now how we now have these tiny ones in the middle of the polygon, the ones and the 4 edges, and the ones in the 4 vertices. I could even go here and say I want to select maybe a mask. Let's go to the ring selection. Let's say that we want to create a mask for this guy. We can just say, okay, we're going to create these points that I'm selecting. With the ring selection, I can even go to the fill selection, and with the shift, holding the shift, I can add this into the selection. And I can save this selection now. I can say this selection, I want to set this selection tag. This selection tag will help us saying, well, these big spheres that I created in the vertices, let's make them bigger so we can obviously see them. These big spheres in this cloner that are, looking at the geometry, we have here a selection tag that I can drop the selection that I wanted to do here, drop it here, and automatically you will see how. Let me turn off the other ones. You will see how these tiny cubes. Actually, let me make this not in this one, but in the spheres and the edges, so we can see it quicker. I drop this selection tag here, and automatically we see how now we created the selection. And now I could be changing the texture in this. I could have this as different passes. Or if I want to add a different effector in here, maybe we want to have a random effector onto this one only, then I could create that too. So again, those little things help us a lot, creating all of these passes that we will be adding into parts of the film or parts of these animations that need to be selected or highlighted in different ways, as you can see here. So I just wanted to put it out there. This is very, very simple stuff that everyone can do at home, and that even this simple stuff that renders very, very fast, we use it as different passes for some of the graphics on these films. All right, so that was the first thing that I wanted to talk about. The second thing that I want to talk about today is how fills and the new volume system that came with R20, and of course with R21, get ready to see even a dial-up version of it, are very, very extremely useful for us. So as you can see in some of the stuff, for example, this is for Blade Runner. Some of these films require a very abstract visualization, whatever is for a planet, whatever is for something that comes from another galaxy. And in all of these, even for Ghost in the Shell, sadly we didn't have the fills and volumes But now that we have them, we can very, very easily create all of these very organic visualizations. And I want to show, again, you how you can quickly create something that complex with a few steps and the volumes and the fields. Again, all of those are examples on how sometimes we need to create those more organic systems. To start with, I want to show a good example here. Let's load it. It's calculating the volume. A good example of one of these cellular systems or DNA strands could be something like this. And I want to show you how to create something very, very similar to this from scratch. And so we're going to create a new scene. We're going to create some geometry. Let's go with the torus. Torus cose. And the torus, as you can see, we have some polygons, right? What we need to start creating in here, what I want to show you today is how we create a system that is completely parametric, that you can change everything, even after spending these 10 minutes that we're going to spend creating this, you're going to be able to modify it because we're going to do it in a modular parametric system and non-destructive, which is very, very important. For that, I want to play with instances. I don't want to play with torus. I want to make sure that once I create an instance, I can drop my torus here or whatever model we want to use. So we're not even going to use the geometry itself. We're going to create these with an instance of a geometry because maybe we want to change this geometry later. And I will show you that too. So to create these volumes, we want to go in here and get those two guys out, both the volume builder and the volume mesher. Now, yes, I could drop the torus into these guys and see this affecting, but I don't want to. I want to show you how dropping the instance will affect. If I drop it into the builder, it's going to create those different voxels. If I drop it into the mesher, nothing is going to happen. So remember, if you want to create the volume voxels, it's going to be with the builder. Now that I see this, I don't even need to care about seeing my torus because what I want to look at is the volume that we're creating. These voxels right now, if you go to the builder, they're big voxels, and I can reduce these to 5, and we can start seeing how the definition gets better. Before we get into that, the definition, I want to show that we have two very important different volume types here. What we're looking here is the signed distance fill, which is almost going to affect as in a surface volume. But we don't want that. We want to change this to fog, and all of a sudden, this fog is going to show us all of these points that are almost like inside of this volume. With this also, if I change the voxel size back to 10, we'll see that we're losing a little bit of voxel quality in here. Let's go back to 5, and let's see how these voxels that I'm creating are going to be detected by the geometry. And the way to do that is the volume mesher system here. As soon as I drop the volume builder into the mesher, we can see here how now we have geometry. So we kind of see the torus back again. Now we have the geometry. And if I change that and I keep increasing the voxel size so we lose voxels, we will see how the mesher will try to interpolate almost as a metable system, the medium points. Let's go back to 5. What I want to start doing to create this abstract visualization is creating something with a random noise. Also, if you want to see any of these meshers and builders, Cineversity has an amazing amount of tutorials, and I recommend everyone going there to see more in-depth, volume learning techniques in here. What we wanted to create is in here and create fill. We wanted to create this random fill. This random fill, as we understand, if you remember the random effector from MoGraph, is going to create the noise. Actually, this is now a random that I can change the seed of, but I don't want this. I want to create a noise. And now we have a visualization on this box of how this noise is going to be affecting. I can scale it up. I can change the noise type. Let's change it to Voronoi, because let's say that we're going to find something very, very organic. So Voronoi is a good idea. Okay, we want to even see if we want to have this animated. We can change the animation speed here. If I click 10 and I press play, we will see how all of this noise is going to be animated. And I will show you that once it's applied to the geometry. Let's say that, yes, we could drop this random fill inside of the builder. But actually, this is not what we want. If I do it, we will see that we're going to start seeing something. And I'm going to jump into this. We don't want to see this box. We want to see this random noise into our torus. We don't want this here because what we want to do is work in a parametric way. What we want to do instead is we want to create a fill group. And this fill group is what is going to go inside of the builder. We can see it here. Now this fill group is empty. But now is when I want to drop my random fill inside. And we want to see this, right? But this is not what we want, because what we want is actually this fill, if I go back here, this fill to be affecting our torus, not a box. So in here, in creation space, we can see that there's this option. You can either have a box to visualize it, or you can click object, and all of a sudden, our noise is applied to our torus. So as simple as that, we can already see now, that animation that I was talking about. It's animated. If I screw through the timeline, let's change it through 300, for example, and we can see more. So we have our noise. Now we can go to our random fill, look at this noise, and say, I want to scale it up a little bit more or less. Actually, we can hide this because what we want to see is how this is affecting our model. Now, what we want to do in this noise is select a part of it. So inside of this group fill and inside of the volume builder here, we will have, let's go inside of the group fill, we'll have something that everyone who's familiar with compositing softwares like Photoshop and all of these different combinations and compositing modes will be familiar with. And here, if I hold, I will see all my modifying layers. I could see something as simple as an invert, and if I drop it, it's going to invert my volume effector. I could do something, which what we're going to do today, like curves. Curves are going to give us a black and white value that is going to, that as I push it, I can select which value we wanna work with. Actually, I don't like working with these splines being Bezier mode, so I'm going to change the spline preset to linear. And as I change that, and I move this here, I can select those 2 points that are selecting that part of the noise. And with Shift, I can move this left and right. So even to introduce some 3D model, or we could animate this by just doing some keyframes on this shape and animating this left and right to see how this comes to life. Even something as simple as that is so quick to create like a volume representation. But this is not what we want to do. If I hit Control and I click, I'm creating a new point. Now I can move this down, and we can see how this is now. Let me move to the right, to the left. Now this is creating something like what we will want. We're trying to create a cellular system, some blobs for Dr. Banner, let's say, is experimenting on something, or whatever it is, Men in Black. And I'm starting to get what I want. I'm gonna just add some size here. That looks cool. Yeah, that could be some cellular system here. But we're seeing something here. We're seeing lots of jagged edges here. I want to create a very, very smooth version of this. And a way to do that, it could be just to go to the volume builder and reduce the voxel size. Actually, I can reduce this to 2, and we will see it's almost like a subdivision. We are subdividing this, but it's not yet perfect. I see these jagged edges. I could see how this is not perfectly smooth. I can smooth that out. There's actually a smooth layer right here, and I could click, and this will be applied to this volume builder, and you will see how automatically this gets smooth. Now, I could do that, but this is not what we want to do. Because as I said before, we want to work in a parametric way, in a way that we can create a lot of different measures and builders, and instead of having to go inside of each measure and builder changing these parameters, I want all of these parameters out in a master effector group. So as you can see, this gray smooth layer, that's not what we want. I'm going to delete it. You can already see what's happening. It's definitely smoothing it out. But we don't want that. We want to go into our volume menu. And here we can see this smooth filter. That's the same. I have it outside now. So I can, like we did with the torus and the instance, or like we did with the random fill and the random group, I can call this smooth filter inside of my builder. I can drop it here. As you can see, it's now blue. And oh, wait, Marty, this is not working. I just dropped the smooth filter. You're wrong. No, because these smooth filters, like we did before, we said remember when we said that there were two volume types. One is the sign distance fill, but this is not the one that we were using for this preset. The one that we're using is fog. So as soon as we change this, now is affecting. Now our smooth filter is affecting it. Now I can go into my filter and I can change that. I can even animate the strength if I want it. You can see how this is affecting. I could even like, you know, just to go quicker, I'm gonna go back to the voxel size to be bigger. But then this is also affecting our smooth layer. So everything that I touch on the voxels and the voxel sides is gonna be affecting this smooth layer because this also has a voxel distance. If I increase this, you know, I'm gonna increasing my my strength as well. Let's say this way, of my smooth filter. It's almost like we have Gaussian, we also have mean, and we also have median. It's whatever feels good to you. I'm gonna keep mean in here. I think like it's good enough. I can see this being a cellular system, and the crazy thing about this is like maybe you don't want to create a cellular system. Maybe you want to create just a design of one model. I could like actually get that shape and use it for my commercial or whatever it is. I can cache that. I can pull that out and get that geometry and do whatever I want with. The new volumes, it helps a lot on something that before we only had the Metable systems to do work with. So again, really, really powerful to create this. I guess for anyone who is into pharma visualizations, these will be like a lifesaver, I have to say. Now, you know, it will say, Marty, you've been talking about parametric ways and different ways to make this a system that is modular. And that's because this is not the only volume measure that I want. I want to create a few ones. So I'm going to rename this to volume measure 1. I'm going to put these guys also into a null. Alt-G to create a null. I'm going to name these, let's call them master effectors. And we have them here, so we don't have to worry about them. Now, let's create another volume measure. Just by copy and paste, I have now a duplicate of that. And what I want to go is inside of my group field. And you remember that when we were creating these curves, we said that this is almost like a selection of that noise that we have affecting the whole volume. If I select this node here, and I move it to the left or the right, I'm going to have the same noise affecting a different part of it. So as soon as I move it out, you can see that I'm creating almost like another layer. There you go. It's the same noise affecting it, but it's a different layer. I have all the control on this. I can actually grab these curves and make them like slightly thinner, because maybe I want this layer here to not be that chunky. I just want almost like a layer that wraps around it. So again, like play with it, have a look at what is the visual that you're getting. And we're going to start having, let's just start having some color here so we can easily differentiate those two systems. I'm going to create 3 materials, double click, quick material. I'm going to, let's say, create one red one, why not? Let's create one blue one, why not? I'm from Barcelona, I'm always supporting my team. And we're create a Football Club Barcelona modular system here. One is blue, one is red. And we can see clearly here. This is our system. It took us, less than 5 minutes to create. If it wasn't because I like to talk a lot over it. And, we can render it here. Here you go. The important part is like that noise is still animated. It's the same noise that we had before. I can scrub through the timeline, and I can see how this very, very like complex system is now being created. Now it says, yeah, Marty, but let's say that I want to see my torus back. I want maybe this to being a selection of that torus affected. Hey, it's okay. This is our volume measure number 2, remember? We want to create a third one. So copy and paste. I'm going to name these number 3. And guess what? We're going to do the same thing. We're going to go into our group film. We're going to go into our curve. And let me just actually drop this white material on this one. So we can differentiate it. And in our curves, if I select this and I move it to the right, we will see how that is sliding to even like another pass. I can even like start playing around with this a little bit more and say like, yeah, now I can see how this is almost like an infected system on this torus. Okay, that's fine. There we go. We still have our noise. Everything is working. Everything is parametric. Now we have these 3 volume measures. And the important part comes now. We've been doing everything in a parametric way. So if I want to now go to my random field where we, remember that we choose that Voronoi noise. Let's say that I don't want this Voronoi anymore. I'm going to try a different one. So I just need to come here, change to a different noise, and all of a sudden, voila, the whole system changed. I don't have to go inside of each one to go change it and whatnot. I can now have all the control. I want this slightly bigger. I can scale this up, or I can scale this down to 200. I will have a very intricate level here. This could be another solution to give to the director 10 different types of this DNA system, right? Anyway, let's say that, I like the Voronoi one. I'm going to go back to it. I'm going to just go back to 800. Our animation, oh no, this animation was too quick. It's okay. I can change the animation speed from 10 to 5, and it will go slower. So all of this is very important because whatever we do with this system now is affecting the whole thing. The smooth layer as well is in the master's effector. If I say I want to change it to Gaussian, it's going to create a completely different thing. I can start now getting into very, very different ways and different designs. This could be something more for your graphic design, for your poster, something that you want to create. And this is still animated. Again, I can still scroll through and change the keyframe here and see how this is all animated. Anyway, so let's go back to where we were, because now that we are familiar with this cellular system, let's say that actually, Marty, we're not having to put this on a torus. We need to put it in a different thing. It's okay. That's why we created that, that's why everything is called into these master effectors. This torus is not what we want. Maybe we want this onto a cube. Okay, I can create a cube. I can drop it into this torus, can turn the torus off, and all of a sudden, oh, wow, this is the exact same preset in a complete different module, in a complete different structure. I could even, if I want, create like a cloner of cubes. Here's my cloner of 3 cubes or 18 cubes, whatever I want to do. These are the guys. I can just like make them. Here we go. This is our cloner. I can change them. I can modify them however I want. And if I drop this here, it's not only going to be created for each cube, but it's going to interpolate the parts that are in between them. So you can see here how the same one is looking at it in the same way that I was looking at the torus. And as soon as I start making them slightly closer, let me change this amount of the Y separation to 150. It's creating it. It's calculating the volumes here. You can see in the bottom. You can see how now it's creating this thing. We could animate these. We could put whatever we want into this cloner. Now, this also works with very complex models. Let me just go quickly to maybe this one. We have this guy here, right? You remember this guy? Yeah. So we can drop this guy too. We can grab these. Let me just get rid of that hair render. We don't need it. I can grab this model. I can go back to my untitled file that I did not save, and I could lose all my work now. I will go back here. It's going to calculate all of this. Let me stop the cloner. Let me actually we don't need any of this cube or cloner anymore. And what we're going to do now is not our torus, remember. It's not our torus anymore. It's our good friend, Iron Man. Now, our good friend, Iron Man, let me make him a bit bigger. So we can see how all of the... Oh, my God, look at this. It looks like from Halo now. Wait a minute. I created Master Chief from Iron Man. Anyway, I know why that happened, but I'm not going to go into it. I'm going to drop this here. I'm going to kill my torus. And, of course, this is a very intricate system now. We can see how, the only thing we're creating here is this. Actually, let me go into my master effector, turn the smooth filter off. So we're going to start seeing this. This could be like we did with the point cloud. We have rendered Iron Man. We put the point cloud in the, on the helmet or whatever selection we want. We might want to create this meshy filter around him. Maybe it's an infection or something. The good thing is, like, the animation that I had is still here. I can still scroll through it, and we will see how these points go out and move. Actually, I do have another, you see, remember, like, Iron Man, like it's opening, the whole chest is opening, and this volume is now looking at it. I actually could go into this random fill again and change the scale. I could change this to a very, very tiny one, and we have now, a system of these little particles that we could smooth it out as well. I could change the different noise. Let's change this to the box or dance. Like, let's go to get some boxes out of it, and we can see here how all our geometry is here as well. I could go inside of my builders, and this is something that you could also do in a parametric way. I could change that to be a very, very tiny voxel size, and we will automatically see how we now have a very, very dense thing where we see, let's go to the beginning, so we see this mesh back. We can see how this mesh that we created is now affecting in the same way. Again, this random fill now is creating cells. Let's go back to Voronoi or Perlin or any of the noise that you want to try. And now we have our animated noise this is still animated, affecting a completely different geometry. So again, like I think this is a very, very powerful thing for designers, for whoever is doing visual effects to create these different passes and whatnot, and we really like it, and especially to create these very, very organic animations and organic things with the fills and the volumes and measures. And again, for this, I only use the random fill, but make sure that you explore this because the possibilities are infinite almost. Like inside of fills, you will have lots of different effectors that you can tap into formulas, into sound, into all sorts of things. And we can, and you can use this for also other, with other different types of volumes. But remember that we can even like be inverting some of those. We could use any of those tools here, any of those modifiers to also change things into that visualization. So again, this is one of our favorite new features. I've been here now for 40 minutes, so I'm going to just quickly go through another very, very interesting thing. I'm going to just spend 5 minutes for that one. And this is how important is that we can now import Alembic files. We did this beautiful trailer with these little fellas. These are called the Blancos. Blancos is a new video game coming up soon. And we only had just like these little guys animated. Our team of animators were actually giving us, the Cinema 4D team at Territory Studio, all the artists that are working with it, wanted to render with Cinema 4D and do all of that. So we created all of these walls with Cinema 4D, and what we wanted to do is to import all of these great animations. And we created this trailer. Now, this trailer is something that you will say, oh, there's a lot of animation here, especially when you see all of them dancing. But all of those animations were imported as Alembic. We didn't need any rig system. But you can see the amount of people dancing here, and all of these guys. Oh yeah, you will see that, wow, you had to animate lots of guys in here, lots of Blancos. Actually not, we animate only 10, but thanks to Alembic, we could start dropping them, change their textures, make them look like a completely different character, and then, scroll through it. And I want to show you how quick this works, in less than 2 minutes. I'm just gonna dive in, show it to you. You know the amount of guys here dancing. Let's finish the trailer. And we also created this in 4 weeks, which was crazy, right? Like, we don't have enough time to be animating lots of stuff, so let's reuse lots of this stuff. And the great thing with Alembic is, like, whatever you import Alembic, let's wait for this to read the Alembic. Okay. We're waiting for this to... All right, I think it's reacting. There we go. So, there's a lot of information here, but look at how quick I kind of scroll through and see this animation here, right? It's insane. It's here. And actually, the good thing about it is I could merge another animation. Let's just merge a different one. Let me go back to my Mario Mance's Alembic. And let's say that I want to add a completely different Blanco. I see here some of those. Let's just add this guy, maybe. Let's just add this guy. I merge it. It's here. I can put it with Alt J into a null. This is our guy. Let's find him. Let's press H. We'll see now the whole thing. And let's find this guy. Let's see where this guy is at. Oh, here he is. Oh, okay. I can have this guy now. It's the same guy here, but maybe I don't want him to be doing any of that. I could go to select my Alembics. I can offset all these animation, right? This guy is here. He's not doing that anymore. I can just drop him here in the background. And now, as simple as that, I have my master animation, and this animation is here. I can start importing all of these guys that we animated, one guy dancing, offsetting this time here, because so the animation in these 3 seconds of that shot is not exactly for all of them. It's just they look like they are all different. This is extremely powerful for when you don't have much time and you need to be reusing some of these animations, importing great animations from all the softwares if you want, and then using them in that way. So again, I think with that, I have to say thanks to everyone for being here. First of all, thanks for Maxon for having me here. For everyone who made this possible, feel free to get in touch.
That was pretty cool. I haven't used the fields, but I think if you can make like procedural systems like that, where you can just go in and change the noises to give you completely different animations, like that is going to save you so much time. You can do all of these different iterations so quickly. Let's see, I was checking out Twitter. I'm gonna check out some of these links. The Blender reel, let's see what this is. That's pretty sweet. Blender is the free one, right? I haven't used Blender, but yeah, I can do awesome stuff in it, I'm sure. Let's see what this is. This is some kind of augmented reality contact lens. Now that's nuts. AR contact lens? Like, come on. Samsung wins patent for augmented reality contact lenses. I wonder how far off this stuff is. Like, to make a patent, it does not take that much. U.S. Patent Trademark Office published a granted patent for Samsung earlier this month for augmented reality contact lenses to get around Google's awkward glass product that was receiving constant negative reviews, mainly due to its face camera being seen as an invasion of privacy. You wouldn't even know if someone had one of these contact lenses on. Samsung invented specialized contact lenses with a hidden camera built in. The main selling point of Samsung's contact lenses is that they're primarily designed for realizing augmented reality. Samsung notes that an external device, like a smartphone, may include a program interacting with a smart contact lens. Dude. This is like sci-fi shit. I would try one of these out. What else does it say? Yeah, I wonder how far off some of this technology is. In the smart contact lens, the display unit may be disposed on the surface of the lens or in the lens. In display region may be adjusted. Therefore, the field of view of the smart contact lens may be much larger than that of projection type smart glasses like Google Glass that have been introduced. I don't know what to say about that. Show me a working product. Let's see if there's any more tweets. Oh, this one I was gonna check out. Real-time live. I wonder if there's gonna be a live stream of that. Oh, here's some AR goggles. Dude, give me contact lenses. I don't want these I don't want these lame glasses. Let's see, matching prescription and visual acuity. Dynamically foveated augmented reality display.
Matching prescription and visual acuity towards AR for humans. With over 60% of the population wearing glasses, incorporating prescription lenses into AR displays is vital to increasing adoption. Today, commercial prototypes offer additional prescription lenses or a glasses-compatible design, but this increases size and weight of the devices. Our work takes the opposite approach, incorporating a functional AR display into a prescription lens. To match 20/20 acuity across the field of view, an AR display would need to provide 400 megapixel resolution, but driving a display at this resolution requires too much bandwidth, power, and computation to be feasible. By combining a low-resolution image in the user's periphery with high-resolution inset in the fovea, we can better match the display's output to the human visual system's performance. In this installation, we demonstrate two novel wearable augmented reality prototypes inspired by the human visual system, foveated AR and prescription AR. We demonstrate prescription AR, a set of 5mm thick corrective lenses with an embedded AR display. This design promises to increase accessibility and integration for users with prescription lenses for myopia, astigmatism, and hyperopia. The prescription AR display uses a beam-shaping lens and an in-coupling prism to relay an OLED image to the eye via total internal reflection and a half-mirror-coated free-form combiner surface. Our prototype corrects the viewer's vision while delivering an augmented image located at a fixed focal depth. The display provides a resolution of 26 cycles per degree over a 32-degree field of view. We demonstrate a dynamically foveated near-eye AR display that closely matches human visual acuity. Our foveated AR display optically combines light from two sources, a high-resolution small field of view foveal display and a low-resolution large field of view peripheral display. Our display provides a resolution of up to 60 cycles per degree in the fovea with a 12mm dynamic eye box. The design covers a diagonal field of view of over 100 degrees. This is a rendering of our wearable prototype. In green, we visualize the optical path of the peripheral display. The HOE is moved to keep this viewpoint aligned with the user's pupil center. In orange, we visualize the optical path of the foveal display. An image of the micro OLED, which is also moved along with the eye, is reflected by a half mirror and delivered to the user's eye via an image combiner. A motor drives a double-threaded screw that moves the OLED and HOE at a specific travel ratio of 3:1. We aim to forward human visual system-inspired displays that integrate system-level solutions to technical challenges and address the needs of the broadest possible user base. Through improving display experiences and expanding the availability and integration of prescription augmented reality, we hope to one day make AR a reality for everyone. Foveated AR, dynamically foveated augmented reality display. Human vision spans a 180-degree fovea, a high-resolution, small field of view foveal display, and a large field of view, low-resolution peripheral display. Our concept includes these labeled components. In green, we visualize the optical path of the peripheral display. The holographic optical element refracts light to create a Maxwellian viewpoint of the display at the pupil center. With a 12mm dynamic eye box, the design covers a diagonal field of view of over 100 degrees. We visualize the optical path of the foveal display. The light rays of the micro OLED are reflected by a half mirror and delivered to the user's eye by an image combiner. We use infrared LEDs to illuminate the eye invisible to the user for eye tracking. The infrared camera captures the user's eye on axis through the half mirror. In this animation, we visualize the movable parts of the augmented reality glasses. Our display design includes a linear stage for moving the HOE and the micro OLED on a slider along the horizontal axis accordingly to the gaze direction of the user. A motor drives a double-threaded screw that moves the micro OLED and HOE at a specified travel ratio. This diagram shows dynamic eye box expansion enabled by our HOE shifting method. Previously, Yang et al. Proposed a similar eye box expansion method by moving the effective projector location using a MEMS mirror. Compared to their method, our HOE shift method provides a larger eye box at the given field of view. We made 3 different image combiners which provide 60, 40, and 30 cycles per degree resolution in the foveal region. To verify our idea, we built an optical bench prototype and a wearable prototype. For the wearable prototype, instead of a motorized stage, we used a thumb screw to enable manual horizontal motion of the displays. We measured the MTF of the foveal and peripheral display. The foveal display provided 30, 40, and 60 cycles per degree. Our peripheral display provides sufficient resolution for far peripheral vision up to 42 degrees of eccentricity for a total field of view of 82 degrees. With the dynamic eye box technique, the prototype covers plus minus 20 degrees gaze angle while preserving resolution and field of view. To correctly register foveal and peripheral displays, we calibrated color and geometry of both displays against each other. For intensity and color, we measure each display's output with a spectroradiometer and rescale the color output to the overlapping gamut. For smooth transition between foveal and peripheral displays, a blending using linearly increasing Gaussian blur is applied to the transition region. Here we show the display results from our prototypes. This is a video of the moving foveal inset without the blending applied. With activated blending, the discontinuities between foveal display and peripheral display are removed. The prototype covers plus minus 20 degrees gaze rotation. Our benchtop prototype also supports accommodation. The foveal plane is moving back and forth by moving the microdisplay and shows clear defocus when the camera focus is changing. This full color picture shows the matching focus and defocus of our display with the rendered content. Our work demonstrates that a compact foveated AR headset is feasible.
That's pretty interesting just to see like all the technical things that they have to consider. I guess specifically for I guess they're trying to recreate prescription glasses, prescription embedded AR display. It was very interesting how they have to consider like the resolution and all of these different technical aspects of it, and also all the tests they have to do and all that data that they're gathering. It's pretty interesting.
having to make it really low counts. Also, if you have huge scenes and you have like 1 million characters like just animating, it's really good to just get into the rhythm of making everything lower poly counts, and then you can just go up after by putting them in subdivs and stuff. Also, it leads to better edge loop management for easy UV mapping, because nobody likes UV mapping. Am I right? No one likes UV mapping. If you have good edge loops, it's really easy to just like select a whole loop and then you can just cut it. If you have like really bad geometry, it's like super hard to do that. It also leads to easy skinning for rigging, so you can like select a loop and then you can just assign the same weight to one bone, so much easier. And better deformations for your mesh for animating, if you're using pose morphs, or even just when you're bending a limb, like when you bend your arm and you've got some really nice loops going around your arm, there's not going to be any weird like stuff. And also, cleaner topology leads to happy artists, where if you're just the only artist doing it, you'll be happy. If you're sending your models off to someone else, they'll be happy. Just everyone's going to be happy. So before I actually get into anything 3D, I can't stress more than planning your model, like planning your character beforehand. Coming from a design-led company, we always try and plan our model beforehand and get the client sign-off. So I'm going to talk about this character, which I did at Animate, a little personal project that is an initiation kind of thing called props. So everyone at work writes a little prop on a piece of paper, and we put it in a hat, and then I pick out a word, and then I have to make a 30-second animation out of it. So this is a character that I designed for it. I wanted my 3D to look really 2D. I wanted to try and do something new. Basically, every time I do a character, I will always draw it out like this. I've got the in-situation kind of pose, and then I've got the A or T pose, whether you want your arms to be out straight or to the side. With my character, she has really thick arms, so I did it to the side. Also like the side and the top. So when I actually go into 3D, I will bring these in as planes, so then I can model exactly to that character. Another thing before you start modeling is thinking about the way that your character moves. So in this case, with the same character as before, I knew that she was going to have a few mouth movements, but before I actually went into 3D, I wanted to think about how the topology was going to look on her face, because she was going to have really exaggerated mouth. So I drew a few little bits and pieces. Here's an example of me drawing over some basic topology. You can see I really looked around the mouth carefully. And this over here, this one is the final model. So it's pretty similar, maybe give or take a little bit, but this, yeah. Basically, that's how I will start off before I actually get into 3D. So now I am going to go into 3D, but I'm not going to show off my models just yet. I want to talk real basic topology, because I don't know if anyone else here knows much about topology and how important it is, but I've got to talk about it now. So good topology. This is a quad. We like quads. Tries, they're okay. Like people in games use these to make their poly count a lot less. I personally don't use them. I never really made anything with games. I made a few Unity stuff, but it subdivides your quads anyway. This dreaded N-gon, be gone. No. On a character that's moving, don't use these. If you can only get away with using these if you are hard surface modeling and you're not going to subdivide, it's fine to use this. Like, I'm not saying you can't use them, but in my talk, and I talk about characters that are moving, don't use them. They're going to look terrible if they are. I'm just going to go into this file. Ooh, which one is the good model and which one's the bad one? So, as you can see, I originally made this one for a little project at Animate, and then I really tried to not die and do this one. I tried to make it as terrible as I could. Sadly, there are people out there that model like this, and I'm not saying that you're horrible people, but it makes me cringe every time I see it. You can see that there's like, this is subdivided, and you can see there's a few weird displacing bits. You can see she needs to like face cream or something. She's got quite a lot of wrinkles. I'll turn back my lines on. I've got like a triangle, a weird end gone here. Just you can see that one. That one's terrible. And then look at that. It's making my eyes water right now. I'm going back. Ooh, can't look at that anymore. The next thing I want to talk about is folds. So when you're modeling, these two examples, they look great. Like it's like that's really nice topology. But then as soon as you go to the side, you notice that, especially on this one, there's some weird, I don't even know what you would call that, but yeah, it's not calculating properly. Whereas you look at this one and it's nice and it's following the topology. So this is a good example, and I'll go back to my characters before. You can see like around the nose, there's no real definition, but then you look at like this character here. I've really made a really nice loop around the nose, so then you're getting that nice definition. So yeah, that works for like if you're doing like underarms or around anything really. So I'm going to go back to this. The next one is dreaded polls. So I have noticed online a lot of people always ask, what do I do? Is this bad? Can I have this pole here? What should I do? How do I move it? Blah, 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 blah. Well, I'm going to take you through how to move these dreaded poles, because you can't get away with not using them. They're always going to be in your mesh, but you can easily move them around to a preferred place, so then they're not obstructing and making any weird pinches on your model. So this first one is 3 edges into 1 vertex. Occasionally this one will come up, especially if you're doing some loops or trying to reduce your edge count, getting your edge loops constrained into like maybe 2 going into 1 kind of thing. The next one is the main, your whole mesh is usually going to look 4 into 1 point. The dreaded 5 into 1 is probably the worst one, but we can't avoid those. I'll teach you how to try and move them around. The 6 or more, I usually try and not use these, but I know like in cinema, if you create a sphere or a cylinder or any of these things, they're going to come up with this kind of thing at the top. Personally, the only time I will leave it is if it's like an eyeball or something and it's not going to be deforming too much. But most of the time I will subdivide that into quads, but that's just personal preference. I'm a bit anal like that. Another thing to think about is edge reduction tips. So as I was saying about this 3 into 1, this kind of occurs when you're trying to reduce your edge flow throughout your character. So in these kind of situations, this one is 2 going out as 1, and you can see that I've got an L-shaped loop going in there. That's good for maybe a jawline or on your hand and that kind of stuff, like just moving your geometry to flow with your forms of your character. The next one is 3 into 1, and this is like, you can imagine this around like a mouth or an eye or something like that. 4 into 2 has just got an extra line in the middle, as same as the 5 into 3, it's got 2 extra lines. The 6 into 2 is actually adding in an extra loop in there, so that comes in handy. And you can see I've got a hand, just one of my hands that I've had from one of my characters. I've got some. You can see that I've done some of these techniques to reduce the flow going up the arm because I didn't want to have 2 extra lines coming out here. But you can see that I've followed the contour of the hand. So when it does bend, it will morph nicely when it like grabs something or anything like that. So that's just one thing. I'm going to go now back into these characters, and I'm going to show you one by one a few of my ways of moving some of the poles. So I'll firstly talk about how to move this 3-edge pole. I've got 3 different forms. Today I'm going to, I don't know if you guys know many of the polygon tools, but if you click M on your keyboard, it comes up with a whole bunch of tools. And in this case, I want to use the knife tool for this first part. So I'm going to press MK, and I'm going into points mode. Basically, this first way of moving the pole is going to be adding in one edge, but then removing another edge. So you're not actually adding in any extra geometry, but you are going to be moving it around. So I'm going to start off by cutting through this part. And you can see I've got this triangle here, and I don't want the triangle. So I'm going to go into my edge mode, and I'm just going to select these edges. Basically, imagine this continues going. For this exercise, I'm not going to select the whole thing, but I'm going to use another tool, which is going to delete these. So it's called the dissolve tool, and if you press M and N, it's gone. So as you can see, I've moved the pole from this point to this point, and you can continue doing that as far as you want to move it. So that this is my most likely way of moving my pole when I am doing retopologizing. I'm just going to undo all this to work on the next way is adding in 2 lines. So this is going to be if you want to have extra geometry in. So this version, I'll cut through here again. And then I'm also going to cut another one through here. And so that's going to be, if you can imagine, that continues off in your model. However, if you got nice edge loops, in this case, this one doesn't, but oh well. I'm going to select this line because I do not want these tries, and I'm just going to dissolve it again. So as you can see, I've moved the pole from here to up here. I'm just going to undo that again, and I'm going to show you the final way of moving the pole. So this version is actually going to delete 2 lines, two rows. So I'm going to cut across here and here. And so now I've made this weird 5-edged and gone. It's not going to be there soon. So I'm going to go back into my select tool, and I'm going to select this edge and this edge. And I'm just going to dissolve them. And dissolve that one too. So as you can see, I've moved the pole down below here. Now, another thing is you can cut these edges any way you want. If you want your pole to go up the top, you can cut it in a different way. So it's quite versatile in that way. So I'm just going to undo that again. And now I'm going to take you through moving this guy, the 5-edge pole. So this one is very similar to the way that I showed you the 3 last ways to move things. I'm going to use the cut tool again, but this one is a little bit more tricky because I'm going to use another tool in a second. So this is adding in 1 edge and deleting 1 edge loop. So in this case, I'm going to add an edge loop going through here. And now I'm going to go into points mode because what I'm going to do is I'm going to select this vertex, and I'm actually going to weld it to this vertex. So if I go M and Q and press Control and click onto the preferred vertex that I want and release, I've now welded it to that vertex. Now I'll just go back into my edge selection and select this edge and dissolve it. And now I'm going to dissolve this one as well. And as you can see, I've moved the pole up here. So it was here, and now it's up here. So that's the first way of moving your 5-edge pole. Now I'm going to undo that all, and I'm going to take you through the next one. So the next one is adding in 2 edges. So I'm similar to the last one. I'm going to cut some extra edges here. So, and then I'm going to add another one down here. There you go. And I'm going to go back into selecting this edge, and I'm just going to dissolve it. And now you can see that I've moved the 5 pole just next to it. So I'll undo that again, and the last version is to, you're basically getting rid of 2 lines again. So I'm going to go back into the knife tool and simply just cut a line through here from, you could cut it this way or that way, you know, any way you want to move your pole. And I'm going to go back into selecting. I'm going to select this edge and dissolve them. And now you can see my 5 pole is moved all the way down here. If you wanted to like move these around, I'll show you a few extra tools to move your geometry. But for now, that is how to move your poles. So I just want to show you, I've actually, I'll just undo all that. I'm going to turn on my subdivision and turn off my wireframe, and I've actually animated these characters. I just want to show you that you can see in this character, it's a bit shiny, but you can see that there's really nice deformation going on around here. But you look at the other one and you can see that there's this weird, that's like a 6-sided pole, like pinched in the corner of the mouth. Sadly, I've seen a lot of models that some reason people do that. I don't know why. You don't want to do that because it's just, you can already see that it's causing some weird issues. So I just wanted to show you animated. So now I'm going to show you more of my characters. So I have a few characters here that I've made in the past. This one from previously from my drawings that I did before. I've highlighted all of the edge loops, and I love edge loops. I have dreams about edge loops. I talk about edge loops all the time. I love them. No one really understands me, but I hope other people will now. I love edge loops too. So I want to highlight around the eyes of all of these characters. I've actually animated these guys with some pose morph tags. I use pose morph a lot with my animation, with facial like morphs and stuff. It's really super simple to use. Sadly, I don't have enough time to go into it too much, but you can always ask me questions at the back. So you can see that like the eyes aren't looking terrible when they close. The mouth is like nicely deforming. There's no pinching. I'll look at this character. She's got quite large eyes, and it's looking quite natural. You can see also that I've placed my poles in specific areas. So my rule is I always try and put my 5-edge poles as far away from the most deformed part of the face. So usually steer clear of the mouth and the corners of the eyes. I always try and keep them as close as possible to anywhere that it's not going to move as much. So you can see that I've got a nice loop around the nose as well, and so it's caused a few poles there. But as I said, you just can't get away with not having poles on the face. You just have to be really strategic in where you place them. The same as this character, I haven't got any poles around the corners of her mouth, and her pole is like all the way up here and a little hidden one underneath her nose. She has very abnormally large eyes. So I tried to make the poles as far away as possible from any of the deforming parts of her eyes. So that's a few of my characters. I do admit, as I was learning how to do good geometry, I really admired people's models, and putting these colors around your edge loops really helps to kind of work out whether or not you've got good geometry or not. I think I'm always on Pinterest looking at other people's work, and that's just how I've managed to pretty much self-taught myself how to do good geometry. So who knows, maybe I'm not actually very good at this, and this is what I think it's supposed to be, but yeah, it works for me, and I hope it works for everyone else if you're inspired to do some more characters. It's not so scary. So the next slide I'm going to go into is actually not a human. It is, I'm going to say a puma. I made it just one night, and I was like, oh, I'm going to make a cat. So this actually didn't take me very long to make. I'm going to teach you how I actually created this guy just really quickly. An old way that I used to model at university, I remember I had one class and we learned how to box model. And I'm sure maybe anyone else out there has learned about box modeling and literally starting off with a cube. Here's my cube. I'm just going to turn on my wireframe so you can see my subdivisions. So basically, as you can see, I've got my front and side view. You can see from in all my viewports. This cube, I have deliberately got cut right in the middle, because what I will always do is symmetrize all my characters. So what I've done is, I'll show you in the next part, is a subdivision surface. I always put this in because if I have a really low poly model, I will always try and put extra geometry into it to look smooth. But when you have really low polys in the first place, it means that doing your subdivision is not going to break your computer. So I'm just going to turn that one off and show you, this is my base mesh. What I've done is I've got a symmetry tool, which you can find in under this menu. I love all these really awesome intuitive stuff. You can so I use in this case this symmetry, and I put it in a null because sometimes I might like create eyes or eyebrows or noses or anything, and they might be separate from my cube, and I can continue putting them inside my symmetry without having to put numerous symmetries. So in this case, you can see, I'll turn off my symmetry, and you can see I've got half a cube. If I go into all my views, you can see I've started to mold it to the face. And the way that I did this was I just went in and had the move tool and moved it around. There's also some really cool sculpting tools in Cinema 4D. So if you I use this shortcut a lot. It's Shift C, and I can search anything in any tag, any tool, anything I want. And if I my favorite tool in the sculpting tools is Smooth. And this one here, I can basically smooth my points. And over here, you've got like your pressure and your size and all that. You can also use like, I don't actually know, the wiggly bracket tool. Someone tell me what that is. I don't actually know what that's actually called. That's how you go bigger and smaller. So I'll just undo what I did there because it was awful. You can also find all this stuff in Sculpt and Brushes. Sometimes I will pull that out and I can easily just get into any of these. You've got like your pull, you can move things around, pull them around. You can grab tools and move your points around freely. I won't go too much in detail with all these because they've got so much involved, and there's plenty of other tutorials that can take you through sculpting. At this stage, I have very minimal amount of points anyway to move around, and I like to stay that way while I'm box modeling, because then I can easily just like move things with just the move tool. I'm going to show you quickly, once I've gotten to this stage, kind of really base model, how I start to add in detail. And I always start off with the eye.